Good afternoon, dear students. This is Sultan Hussain, an MTech student from NIT Agartala. Welcome to your first class by Professor Mehdi Zare on disaster management. Professor Mehdi Zare is the Professor of Engineering Seismology at International Institute of Earthquake Engineering and Seismology, that is IIEES, Iran. He is also Associate Member, Academy of Sciences, Iran, HDR University, Strasbourg. He has been the Director of Seismology Research Center of IIEES, followed by IIEES Vice President for Research and Technology. Professor Mehdi Zare has also been Director of National Center for Earthquake and Prediction. Professor Mehdi Zare will be addressing you and taking a class on disaster management in a few minutes. Sir, can you hear us? Mehdi sir, can you hear me? Yes, sir. Yes, sir. You are live, sir.
I start? Okay.
Yes, sir. Yes, sir. You can
Okay.
start.
Good afternoon, ladies and gentlemen. Many thanks for your invitation. Many thanks for your efforts in order to develop the science and knowledge on earthquake and natural disaster management and reduction, for which all of us are doing our job in the framework of reducing the natural disaster risks. Our aim is to diminish as much as possible the possible losses of a disaster. Therefore, we know very well when there is a disaster, there is not a good condition, there is not a nice condition, but the art of disaster management is to select the less worse condition. Therefore, this is the thing that the people who are involved in disaster management are engaged. We all try to diminish the losses, the possible losses, and we try to conduct the situation in order to have a good selection of less worse condition, not a good condition, because there is no good condition in the disaster case. Therefore, we manage the risk of a disaster. Okay, in this course, which I have designed it in 4 steps, I will try to represent the basics of disaster management, means the cycle of disaster management, and to be focused on crisis and on disaster. What is a disaster and how it may cause damages toward the human settlements and due to the possible vulnerabilities. Okay, why we call it disaster management as a cycle? Because it repeats. This is the rule of the nature. When a disaster, when a phenomenon occurs, it is clearly an event to be repeated in the future. Therefore, we do the efforts in order to prevent the losses. We try to be prepared before the disaster strikes, and if it happens, the response, the good response, will be given to the condition, and the restoration will be possible as fast as possible, and in the best case, depending on the conditions. Therefore, when the restoration is taken place and reconstruction has occurred, we know that the future disaster may occur again. Another event, just as it happened before, may be repeated. Therefore, the reconstruction may gives and should give a mean to the society of to be better prepared for the next one. Might be the same size or a bigger crisis, or I mean a bigger disaster. Okay, we use sometimes crisis, sometimes disaster. What is a crisis? Crisis is a threat to core values or life-sustaining systems, which require an urgent response under conditions of deep uncertainties. What it means? It means that when the response, the possible response is less than the dimensions of the disaster, the conditions might be chaotic and a crisis may occur. We our capacities to respond, if it is not as big as the size of the disaster, the condition of crisis might occur. And what's the disaster? Disaster is clearly when a hazard causes damages due to the possible vulnerabilities. In the United Nations documents, the disasters are mentioned to be the condition, a hazardous condition, that the losses are resulted, and there are more than 10 people killed, or $100 million losses. But in several different documents, it is mentioned that these levels of, triggering for the definition of disaster might be different in different countries. For instance, when a disaster, when we want to define a disaster in the city of New York, it might be different. The condition might be different comparing to the city of Kabul in Afghanistan, or to the condition of how to say, Kuala Lumpur in Malaysia. Therefore, the level of death and the the base level for losses, the possible losses, are might be discussed in different countries. Even the losses equal to less than 100 million US dollars might be disastrous for the poor countries, for the countries have less means in order to cope with the disaster. However, a disastrous condition means that a situation that there is losses. There are life losses and economic losses. This is a condition of disaster. If such disaster is bigger than our capacities for to respond, the condition may go toward a crisis, and a chaotic condition may occur. Okay, it is always important to communicate crisis, to share the meaning and the definitions of a possible crisis based on the previous occurred crisis in the situation, in the environment, in the country. There are pre-crisis communications in order to be connected to the people. We may use the means such as the messages. We may give orders in order to be prepared better before a possible crisis, and we may prepare a plan, an evaluate plan for the condition that the crisis is possible to occur. The initial stage is when the crisis has occurred. They are expressing their emotions, and they provide their condition through an explanation, and there are the people who may help such people in crisis. And in a maintenance stage, the further explained risk might be given by groups of population, and some supports for response might be provided. We may think about decision, helping the decision makers, and taking feedback for analysis in the maintenance case, and for resolution. What are the possible resolutions for crisis communication? It might be educate public for future crisis, examine the problems, gain support for policy and resources, and promote the organization rules in order to be more prepared. And the evaluation is all the activities that we may arrange in order to understand the lessons, the possible obtained lessons, and to return to precise planning for a future possible crisis. Therefore, for a pre-crisis phase, the core concern is to be prepared and prepare the people and community for a possible disaster which is coming. In fact, the risk of disasters is increasing because of very different things. There are terrorism, there are poverty density, there are aging population, international travel speed is increasing, and emerging diseases such as COVID-19 exist. Therefore, we are in the case of increasing the risks, and the risk and emergency risk communication may help to have better decisions and clarify the facts, involve as participant, not the victim, and take feedback to responders, provide watchguard resource allocation, recover to preserve well-being and normalcy. And in the level of organization, this may help to execute response and recovery efforts and support for disaster management plans, and to control the rumors. The rumors are increasing just after disaster. Always, okay, there are the people who are worried about the condition, and there are, I mean, some intended rumors which give the critical information which are not correct, which are a mix-up of incorrect and misinformation, but they may give attention to the community, and they may increase the level of injuries, illness, and death. Okay, this all of these activities may give help to public response for recovery plans. All activities which are arranged in the family level, or I mean, in the cultural concepts of a society, in order to cope and to recover from a disaster, might be a case for such risk management. Okay, what are the very preliminary definitions of the essential parameters: hazard, exposure, vulnerability, risk, and resiliency. We use very much from these parameters in disaster management. Okay, hazard is normally a condition for natural hazard is a natural condition which may cause damage or loss to human being, properties, buildings, and built environment. Exposure means um, the level of existing people or properties which are exposed to a hazard. Vulnerability is the potential of being or receiving losses and for the people to be killed or due to a hazard. And the risk is the multiplying of these three parameters: hazard, exposure, and vulnerability. In order to calculate the risk, you should know hazard level, exposure, and vulnerability. Multiplying these three parameters, you do have risk level. What does it mean? It means that if you have a hazard, for instance, the possibility of a major earthquake, but very close to a desert, along a fault on which almost nobody are living on the fault or nearby the fault. A major earthquake may happen, but nobody is living in the epicentral region, and even in a couple of kilometers, a couple of 10 kilometers close to the epicenter, there is not a population to be exposed to such hazard. Even when there is no property, building, cultural, things such as a historical monument or a valuable landmark does not exist in the area which might be affected by that hazard, that earthquake. The exposure level means zero or very close to zero. And when the exposure is almost zero, it means that the vulnerability is very close to zero because nobody is there. And if we are explaining a condition that nobody is close or living around the epicenter. Therefore, hazard is multiplying by exposure, which is zero almost, and vulnerability, which is almost zero, and therefore the risk means is resulted in a risk which is zero or very close to nothing. Therefore, we may have hazard, but the risk level might be negligible or zero. And why we emphasize that the people should not be concentrated in hazardous areas. We intend to reduce risk. We intend that as less as possible the people, human being, exposed to that hazard. We think that doing such sparsely populated or zero population around the hazardous areas, we may have zero risk level inside or around a hazardous condition. In the last 2 decades, another parameter has been entered to the scientific literature of disaster management, which is resiliency. What does it mean, resiliency? Resiliency is how you, it is a parameter to define how you receive, how you react to an incident, to an event, a hazardous event, how you show how you are vulnerable and what is the level of losses that you may receive, and how fast you may return to the normal level. What is normal level? Normal level is the level of living just before the incident. The incident wasn't, it does not mean, the normal level does not mean an ideal lifestyle or, life condition. It does mean that the condition in which the people are living, either in a rich situation, in a rich city, such as Toronto or New York, or in a poor city, such as Kandahar in Afghanistan, or how to say, in a poor city that you have a lot of people who are not living in ideal situation. They are living, but they are living in normal situation. Normal comparing to their standard of life, not to the an international lifestyle. Therefore, even if in a poor city or in a poor country, the level of possible damages will not be too much, and the community may return as fast as possible to the normal level after the incident, we may say that this city is becoming a resilient city. Resiliency, therefore, means the level that we receive the damages and speed or velocity to return to the normal condition. As less as possible we receive damages, and as fast as possible we return to the normal condition. before the event, we may say that we are more resilient. Therefore, this is a, a core concept of all the programs, such as the uh, such as the programs such as UNISDR, the United Nations Office for Disaster Risk Reduction, uh, of the, this is international office. The core concept that they use is actually resiliency, especially after 2004. It is more and more entered to the scientific literature of disaster management. In order to promote the natural disaster reduction and natural disaster management, United Nations has organized since the early 1990s, has organized 3 World Conference in Japan. The host country was always Japan, and the first conference was in May 1994 in Yokohama, in Japan. After this conference, the and a strategy and a strategic plan has been developed and published, which is called Yokohama Strategy for a Safer World. This this was the, we may say, the first international strategy in which the international scientists have been engaged and have been involved in order to develop a, a strategy for future efforts, and giving a 10-year time by 1995. By 2005, in which the second World Conference on Disaster Risk Reduction has been taken place in Kobe Conference. A framework has been established as a roadmap for disaster risk reduction. That framework was named Hyogo Framework for Action, HFA, 2005-2015. Hyogo is the name of the province that Kobe city is the center of that province in Japan. Therefore, they named Hyogo Framework for Action. It was an international framework comprising all the efforts and plans that has been performed by 2005, and they tried to include the up-to-date and the occurred events, major events in that framework, in order to be established for the next 10 years, from 2005 to 2015. Do not forget that this conference has been taken place in January 2005. In December 2004, the great earthquake and tsunami of Banda Aceh in the Indian Sea has occurred, and more than 15 countries in around Indian Ocean, including India, Sri Lanka, Thailand, Indonesia itself, Sri Lanka, and even uh, very far countries such as Iran, Pakistan, they there have been damages and victims due to the tsunami. It is a huge number of people which have been washed through the sea because there is no evidence of and no information that a possible tsunami may occur in the coastline, and nobody knew that a great tsunami may occur, but it is occurred in the 26th of December 2004. And this conference, Second World Conference on Disaster Risk Reduction, has occurred less than 1 month after this earthquake and great tsunami of Indian Ocean. If you look at the Hugo Framework for Action, you will see a lot of items about early warning system, about tsunami hazard, and the importance of availability of technologies and facilities for all nations due to the early warning systems. Why this has been included, and the conference have been focused on these items, because when the 2004 earthquake and tsunami occurred, more than 200,000 people have been killed in the condition that nobody knew, and no facility has been available around the Indian Ocean coastline and countries for such disaster, for such possible disaster. Therefore, in the Second World Conference on Disaster Risk Reduction, this item has been included. The item of this important item of the early warning system, and they have included that all people should have the early warning system for their all possible natural hazards by 2015. You know that these frameworks are suggestion, and they are the countries may act positively due to such frameworks, or may do nothing, and such framework and international programs may not ask them why you didn't perform in this way. However, a lot of countries such as India, such as Indonesia, they have installed the early warning system for tsunamis between 2004, 2005, and 2015. And actually, they have the system, early warning system for earthquake, tsunamis, whenever they occur. Okay, it was the impact of that great earthquake and tsunami. And the third United Nations World Conference on Disaster Risk Reduction has been taken place in Sendai, Japan, in March 2015. It was arranged in the fourth anniversary of the Japan great earthquake and tsunami of 11th of March 2011. And the framework which has developed in this conference has been organized for 2013. It means that the previous strategies and frameworks have been developed for a 10-year time. This new one has been developed for a 15-year time span, such as other United Nations frameworks, such as educational framework and UNESCO framework for action, which is developed in 2015 by 2030, and climate change framework, which is developed in the same year. It was the Paris Agreement of 2015, and that framework has been developed also for 2030. Therefore, disaster risk reduction framework, Sendai framework for disaster risk reduction, has been developed for a 15-year time span. And in this framework and program, SFDRR, which was the result of that World Conference, there are one global outcome of this, one goal, 7 global targets, 13 guiding principles, 4 priority for action, and which are organized in 4 levels: local, national, regional, and global. The role of stakeholders have been defined, and the international cooperation and global partnerships have been emphasized. It is now we are in the 5th year after this framework, and it means that 1/3 of the time of this 15-year time has passed. But it means that I think that after 5 years, we are observing that the result of this international framework was effective and meaningful, and it represents the situation, that the actual situation based on the results of the works of scientists and the outcome of the expertise, actual expertise in the world. Okay, for this Sendai framework for action, it is planned to move from disaster response and risk recovery, which is a classical approach due to the disasters, to a comprehensive. This is very important because in most countries, especially in the most third world or underdeveloping countries, most of the effects are disaster management are on response and recovery phases. And a study has been performed in Iran very recently this year, and it is shown that in the last 100 years, last century, the budget which is spent by the Iranian governments in the last 100 years for disasters, 93% of the budget is spent on response and recovery, and about 6%, something around 6% has been, and only 1% is spent for mitigation. Therefore, this might be taken as countries, I mean, underdeveloping countries such as Iran, and we may expect that such condition means most of the budget spent on response and recovery is the more or less same situation in underdeveloping and third world countries, means most of the population of the world. And the major messages was moving from disaster management to disaster risk management. We should move to manage the risk of the disasters in place of the approach to the disasters. They are not accurate. We plan and we start to work on the disaster risks in order to reduce possible risks. And when the disaster strikes, the losses are already under control. Another change of approach was designed in Sendai Framework for Disaster Risk Reduction. Sendai Framework for Action has been placed from what to do to how to do. Okay, if you look at the guidelines and manuals for disaster risk reduction, there are a lot of orders, a lot of good things, I mean, items to be performed. We should settle in a safe place. We should build good building. We should, I mean, keep calm when an earthquake is happening, and we should do this, we should do that, and in all of the guidelines and I mean manuals, you observe a lot of such I mean orders. I mean a lot of these good things to be performed. But the problem, the major problem, is how to do these orders, how to do these good things. If the people are poor, how to they should live in safe conditions. This is the big challenge. We should go to we should attack to these big challenges. It is not the scientists are not the people who provide a list of good things to be performed. They should be the people who think and find the resolution for how to do these good things, and this is this change have been expected in Sendai Framework for Action by 2030. It is a very, very important thing to find the solutions and go through local levels, use the cultural impacts and conditions in order to find these solutions, because you should attract the participation of people and the collaboration of people in order to manage the risk. Okay, I stopped for this session. I have given this preliminary note to for this therefore we are I am ready to, if there is any question or comment, to listen.
Thank you, sir. Thank you very much for your valuable lecture. Now we can take questions. Students, you may ask questions to sir in the comment box. I'll display the question on the screen. If you have any question, you can ask in the comment box. Sir, can you hear us? Rakesh Ranjan has asked one question. If you can hear us, sir. Yes, sir. Can you hear us?
Yes, of course. At your service, please.
Chaudhary Janish is asking, how can we increase our efficiency to predict the disaster?
It is a good question. The science is the science work is to reduce. I mean, to predict the events. Our efficiency might be better in order to have more sophisticated models, better data, and uh, less uncertainties. Um, a combination of more data, less uncertainty on the data, and better models as much as possible, the models that fit with real recorded data, we may expect that our predictions for disasters will improve. And this is the case that we do have um, to perform. I, I think that most of the scientists are working in this way. It means that they are trying to obtain better data and to develop better and more qualified models. And there is another question: can we define disaster at the international unit that it is same for everyone and every disaster? Yes, we can. And uh, the effort of uh, uh, United Nations frameworks or any other international framework is to define the international units, international scales, in order to show as uh, much as possible in a quantitative way the disasters and their measurements in order to make possible comparing the disasters and comparing the measures on disaster risk reduction, because having no scale to compare and no scale to measure if it was uh, effective or not, everybody may say that I was the best and we are doing the best job, a nice job. You know, there should be a scale in order to compare. Therefore, the programs of United States, such as UNISDR, United Nations International Strategy for Disaster Reduction, is aimed to provide such uniform and unified platforms to measure the disasters. Another question: how can we deal with the situation that happened in Nepal during series of earthquakes? Nepal is a good example of a country, of a third world country that has reacted. The scientific community of Nepal has reacted. I do believe in a good way for disaster, especially in the last 20 years. I had three visits to Nepal, two of them in the years 2002, 2003, and one of my trips was after the 2015 earthquake in Nepal. I am familiar with the conditions in Nepal, and I understand the difficulties to deal with the consequences of major earthquakes. But we think that the essential way is partially started to be followed by specialists, Nepali specialists, they are trying to perform in an international style and manner to go through, I mean, international frameworks and in very different disciplines, from disaster mitigation to, I mean, disaster risk reduction. They have performed very good actions. I will try to show some of these works in my second, in the following follow-up lectures tomorrow and next week. Another question, my question is, even if we can possibly predict a natural disaster that is coming, how will it benefit us? If we may predict a natural disaster, it is very helpful, and we may get ready ourselves for a disaster which is coming. We may arrange the things in order to minimize the losses. It is very useful. Don't forget it. But the problem is some of the disasters, actually, such as flooding, they are or cyclones. It is possible that they will be predicted. You see in the news that they are predicted, and they give good, the result of the predictions representing in the media, and it is very effective in order to reduce the damages. But for instance, in the earthquakes, it is not still possible to predict in a precise way to reduce, to have very controlled uncertainty. And this is why that most of the major earthquakes occurs, and unfortunately the damages are still very important. I think that I commented. Another question: is there any device which we can detect the waves produced by an earthquake, like animal can feel? Not yet. There are some applications which you may download from Google Play or App Store, for which some evidences might be reported. For instance, there is an application developed by International Center for Earthquake EMSC. The application name is LastQuake. You may download LastQuake, and it receives the reports of and observe any activities which may represent the condition of an occurring earthquake, or an earthquake has occurred, in order to be declared immediately. LastQuake is doing in this way, and but not yet for animals. Not yet for animals, but for the people, they are good. The reports of the people are arranged and reported by the application LastQuake. Statistical data of a disaster. The statistical data be consistent, should be because data, the may not be useful to
Yes,
predict
আমি আছি, তবে আমার
because
ইন্টারনেট যেগুলো
metadata from everywhere, and you may pool all of these data in uh, I mean on a basket on your computer, but the metadata have a lot of uncertainties, a lot of deficiencies, mistakes, and false events, everything. But if you want to process the data, you should have the way to use the process data. This is very important. The process data, you should have the process data in order to arrange your database. Therefore, the thing that is helpful is a database. You should have a time to arrange such database. For instance, if you want to predict a flood, the situation is different that if you want to predict a cyclone or if you want to predict a landslide or an earthquake. Yeah. And industrial accident like in this incident of Chernobyl can come under disaster. Yes, of course. Industrial accidents are a part of, a form of man-made disasters, and they are classified actually as man-made disasters. They are very well-known man-made disasters, and such as Chernobyl explosion. It is clearly a disaster that is now known, and therefore most of the rules to arrange such disasters and to manage this disaster risk are almost the same that comparing to the earthquakes. Is it possible that we can build a machine that creates large artificial shock waves of some frequencies to cancel the natural tremor of an earthquake and minimize the aftershocks? This is a huge work that I know only, and this is my professor Kayal, who may create a machine to create this. The result. But beside Professor Kayal, this is your job. This is not my job. But it is a very, very different job. I think that it is a long way to go by the scientists still, a couple of decades to go to create such disaster in order to to be able to to make under control especially the major earthquake.
I think sir has lost his connection. He is having some technical issues. So today we have another professor with us, Professor Dr. J.R. Kal. Professor Dr. J.R. Kal is a retired Deputy Director General of Geological Survey of India. Presently, he is working at the Institute of Seismological Research, Gandhinagar, India, in seismology. I request Dr. J.R. Kal sir to address the students because there are so many questions coming related to prediction of earthquake. Even someone has asked about the artificial intelligence and how can we use the artificial intelligence to predict earthquake, and how can we reduce a disaster. One was asking that every year there is, because due to flood and other natural calamities, so many lives are being damaged in Bihar especially. So how can it be reduced? If you can shed some light on these issues about future prediction of earthquakes and possibilities of future predictions. Koel sir, over to you.
Okay, thank you, Sultan. I think it was a very good session or lecture on disaster management, and the basic points should be clear to the students. But I think they are a bit dragged away from the basic points to the earthquake prediction problem. Well, I will take it up later on. Yeah, what is the status of prediction? But before that, I want to clarify to our students some technical points which Professor Jare tried to clarify. I think we must first try to understand those things. What is seismic hazard? You must try to understand what he has meant. He has meant three terms: seismic hazard. Then he has termed that damage. Then he has used another term, risk. You must understand these things first. Seismic hazards means, due to the earthquake, there could be long, fall movement or new ground fractures or some crustal deformation. Those are the seismic hazards. It has been caused by the earthquake, by the shaking of the ground. So a lot of things has happened on the ground. Ground fracture has happened, land movement has happened, land upliftment has happened. So these things are the hazards of earthquakes. Now, then he has used a term, damage. Now, due to this fall movement or fracture development or whatever on the ground, now there can be a lot of damages. The buildings which are standing on those fractures or near to that fractures, or building which has, the subsidence of the land and building has gone down. So these seismic hazards caused damages. Then he has used the term risk. What is the seismic risk? Risk, if you understand, that seismic hazards into vulnerability. There could be seismic hazards in the Jaisalmer desert in Rajasthan. A great earthquake occurred in Rajasthan or in Jaisalmer desert, that can cause, movement of the upliftment of the sand or subsidence of the sand dunes, or large fracture has occurred in the desert. But there is no risk, there is no damage of the buildings or no risk. People are not living there. So you must first try to understand what is seismic hazards, what is damage. Damage means is caused by the ground movement and damage to the built properties, man-made properties. And then risk means how many people are living in there. So how many loss of lives can be there. So that is the risk, and or how much property will be destroyed because of the collapse of the buildings, collapse of the bridges, and so on. So these three terms you first understand, because your questions were whether the earthquake can be predicted or disasters can be predicted. First thing, the answer is no. Earthquake cannot be predicted as of today. So you are engineer, the lives of the society is in your hand. And what scientists can do for you, the seismologists can do for you the seismic hazard map or seismic risk map or microzonation map. That I will be teaching you in MTech course in second semester. So suppose for the city of Guwahati, we have done a seismic risk map. Now, how we have done that? We know that there will be scenario earthquake in the Himalaya or in the Shillong Plateau or in the nearby Guwahati area. So because of that earthquake can cause damages. So first there has to be earthquake which can cause hazards, ground movement, then cause damages. Damages to what? Damages to man-made building, damages to the city. Then comes to risk. So that job is done by the seismologists, by the geophysicists. They do seismic hazard microzonation. Means within the Guwahati city area, what are the most vulnerable zones? There comes the management to take up. So the seismologist can make a risk map. Means suppose the Guwahati city area, we have studied each and every site within 50-meter distance. Each and every site we have measured what is the ground site effect. So that is, that is one of the key factor for the damage. So if there is a ground shaking of some frequency, the ground will be having amplification, ground amplification due to that earthquake shaking. So that we study. That means we try to study how much ground amplification is there, at what frequency that ground is amplifying, and if your building matches with that frequency, building will collapse. So all these things are studied. This will be taken up in microzonation class in MTech. Possibly you have got the seismic science courses. So what I want to tell you is that what Professor Zare has tried to convey you try to understand for these hazards, then the damages due to these hazards, and there will be no damage in desert area, but there will be damages due to earthquake in the city, if that earthquake is very near to the city area. And if there is damages, there will be risk. So seismic hazards into the vulnerability means how many people's lives are at stake. That multiplication is the risk evaluation. So this hazards map, this microzonation map means what are the sites within the Guwahati city, what are the hotspots where the maximum damage can occur. And again, we have calculated how much risk is there, how many people can, the casualties will be there if that earthquake occurs. So that is the risk. So these maps, seismic hazard microzonation map, and then the next product, practical product is the risk map. So we have made a very detailed map and spotted all the areas with red color, that these are the areas which will be maximum risk, where building will collapse, where people will be killed because of the site effect, because of the ground frequency and the earthquake frequency matches, and the ground and the houses will collapse, and the ground and the houses conditions are also surveyed. So disaster management authority has to take action when there is an earthquake in nearby Guwahati area, or in the foothills of the Himalaya, or in the Shillong area, or in the Kopili fault area. The management authority will immediately see the map, which are the area where the maximum risk is there and people are already in high risk. So the management will run there fast for the rescue. That is called earthquake disaster management. Now, you are asking a question whether we can predict disaster. So the solution is that we cannot predict earthquakes as of now. So solution is to make earthquake resilient society. How to make that? To build houses with proper seismic design. So as I said, the city or the lives of the society is in your hand. The civil engineers, if they construct a dam or a nuclear power plant or a big multi-story building on a fault or on a site which is vulnerable for much damage, then your job, that is your concern, how to make a earthquake resilient society based on the scientific data. And what is scientific data? Scientific data is damage and risk. Risk map is there. Microdimensional map is there. Which are the spot where the earthquake will cause damage, and if that damage happens, how much is the risk for the people's life, how much is the risk for the multi-story building, and all that maps are made by the GSI people. So management authority's duty is to extend the rescue operation in that hotspot fast, and the engineer's duty is to, if you make a house or make a big multi-story building, or make a engineering construction, you first see the seismic risk map of the scientist of the GSI, seismic hazard map of GSI. Then you have to design your building accordingly, so that I don't know whether if you have, possibly you have heard the very good lecture by Jim Mori. Professor Jim Mori of Japan gave a lecture on tsunami and earthquakes, and he clearly said that the engineers did good job. There are hardly any casualty due to earthquake shaking. It was 9.1 earthquake, equivalent to 30 or 35 earthquakes of magnitude 8 at a time. It is huge. It occurs, so far it has occurred only 4 in the whole world in our known history in last 200 years. So magnitude 9 earthquake made minimum killing of people due to shaking. The disaster happened due to the tsunami. Now again comes the knowledge of awareness. So the society can be saved by engineers and by the awareness of the common people. I will tell you a story of awareness. During this Sumatra earthquake, a tourist party from England went to Phuket Island in Thailand for holiday, because that was December month. So they went for holiday, and in the sea beach, nobody knows that earthquake has occurred, but in the sea beach, one little girl of standard 5 or 6, 8 years old, maybe standard 6, 5 or 6 maximum, that girl saw that the sea wave receded for few kilometers, for 1 or 2 kilometers it receded from the beach. Then he immediately shouted to her father, "Daddy, a tsunami will come. We must run away from this place." So that is the awareness. That girl said, then their father said, let me listen to my daughter, what she is telling about. Then she said, their teacher has taught in the class that when the sea waves goes receded for abnormally for kilometers, then there is a you have to know that a big tsunami is coming. So that little girl saved some hundreds of people from the sea beach. They all ran away from the sea beach. Now you know what was the awareness for our country's people in Chennai area, in the seacoast people, the fisheries people, fishermen, they were in the seacoast and they saw that abnormal behavior of the sea. So seeing this, they went to village and called more people to come to the seacoast to see the abnormal behavior of the sea. So the hundreds of people from the village came to the beach to see the abnormal behavior that the sea waves has receded. And then the tsunami came and hundreds of people are killed. So that is the awareness, level of awareness. So it is the design, it is the common awareness that if you make a house on a hill slope in Shillong, plateau, or in Sikkim hills, then the building will collapse if it is not properly designed for the earthquake resistant resilient structure is not there. And before making any building, any houses, any project, any multi-story building, any hospital, anything, you must see the Geological Survey of India's map. Whether you are making your building or dam over a fault, or whether you are making a building where the side response is maximum. So these are the cautions those are the teachings. We don't take any teachings from the earthquake. In Bhuj area, the earthquakes, 2001 earthquake, 7.7 earthquake killed so many thousands of people. 20,000 casualties was there. And the Bhuj city is rebuilt, and most of the new houses are again on the fault. On the fault, they have constructed the houses. So it is the fault of the planners, it is the fault of the designers and the engineers. It is not the fault of the scientists. Scientists make their study, they make the fault map, they make the seismic hazard map, they make the seismic hazard microgeneration map, they evaluate the risk map. Even then, the society is not aware. So it is not the question of disaster prediction. Disaster prediction is a very, very vague word. You should say earthquake prediction. Now, Professor Zare has also mentioned another point, that tsunami. I have talked about earthquake, how you can make a resilient society. Now, tsunami, you cannot make a resilient society. Japan, Professor Jim Mori told that the earthquake did not kill people, that many people, compared to 9 magnitude earthquake, only maybe 100 or 150 people are killed, but tsunami killed something like 20,000 people or whatever. So tsunami, and that was beyond their imagination. They had no past experience, and they never knew that the tsunami can be. And nobody in the world know that tsunami can be of the order of 40 meter height. The maximum height is 10 meter or so, and so far in world history. But that tsunami came with a 40 meter height. It is a wonderful lecture. I wish that you have heard it, and if you don't have heard it, then you must go to the YouTube of day 3 international workshop and lecture 1, first lecture on day 3. You must listen to that lecture. Tsunami is not predictable because you cannot predict earthquakes, but warning can be given. Even earthquake warning can be given. Now, let me first clarify what is tsunami warning. Tsunami warning is when an earthquake occurs in the sea floor at a shallow depth with thrust faulting and a great earthquake magnitude 8, then we expect a tsunami will be generated. And that tsunami generation, from its generation and from its reaching to the coast, it takes time. In Japan, it takes half an hour. Within 20-30 minutes, it reaches, because Japan is in the sea coast, very near to the sea coast. So any earthquake in the sea, the tsunami reaches by 30 minutes maximum, sometimes 20 minutes. But for India, the earthquake source zone is Andaman, Sumatra Islands, where large earthquake can occur and tsunami can reach to the Indian east coast, to Japan, to Chennai and all, to the eastern coast. So India is much in a better situation, and that tsunami will take about 3 hours to reach to Indian east coast from Sumatra or from Andaman with the normal velocity of the tsunami. So, but India had never experienced any tsunami during the last 500 years. Maybe in the paleo time there had been, now scientists are doing investigation. So India had no tsunami warning system. But after the Sumatra earthquake, India has developed tsunami warning system. And we are much it's a very state-of-the-art techniques has been applied in this warning system, and people are doing good job. In a sense, there had been a great earthquake near the south of the Sumatra island, and they immediately warned that a tsunami may reach to Indian east coast. Then within 10 minutes they know the earthquake has occurred. They can locate the earthquake that it is in the sea, and the tsunami can generate. Then within half an hour or so, they can do the fault plane solution or focal hot source mechanism of that earthquake, and that can infer whether tsunami will come or not. Then they found that it is not a thrust earthquake, it is a strike slip earthquake. Then they again warned that was a false alarm, tsunami will not be generated. So what I want to say, that we had no tsunami system. First thing, that we have only two sources of tsunami source. One is Andaman Sumatra region's earthquake, and another is in Arabian Sea near the Kutch area, that Makran trench. So we have two tsunami sources, and our coastal areas are much away from those places, except that western coast, which is near to the Makran trench. But no great large earthquakes is expected there. Only 7 earthquakes, maybe historical record is there, or so that is not a very dangerous tsunami-genic source zone. But definitely Andaman or Sumatra is a tsunami-genic zone, and tsunami warning can be given, because we have got 3 hours in hand. We have got enough time, to run away from the coast. Just you go away by 1 kilometer by walk, 10-15 minutes, or by run. You just run and go away from the. When you see the sea waves has maybe abnormal behavior, instead of standing there and admiring what is happening, you better run away. So that is the lesson I think one should take. So tsunami disaster can be handled by the warning system and by the common sense and awareness. So far the flood and cyclones are concerned, I think they are predictable. The meteorological department is now doing good job to predict cyclone and storms and other things, and that you cannot stop. Natural things, natural disasters you cannot stop. Certain disaster you can, like cyclone, floods and other things, that you can predict. And tsunami also you can give warning system. Warning it takes about 20 minutes to half an hour. Say Japan can do this job within 10 minutes, and they immediately broadcast tsunami is coming. So, but the way the Sumatra tsunami, the Japan 2011 tsunami came, that is something different. It came 40-meter height, means 120 feet height. Tsunami came. So that was beyond imagination and beyond control or whatever. So tsunami warning system can save people's life, and meteorological system also can take precautionary measures for reduce not. Whether your artificial intelligence can do it or not, that I have no comment. That only your generation will see, and we hope that our next generation will be able to do the earthquake prediction. But as of now, earthquake prediction is not been possible, but earthquake disaster mitigation is definitely possible based on the scientific map and scientific data. Earthquake warning system has been made, that is very much in use in many countries like Japan and all, but that is not really for it cannot save much people, because that is only when the S-P time, if you understand that earthquake comes with a first P wave and then S wave, when that S-P time, is about 50 seconds or so, then you have got 50 seconds time, and that too you have got, to locate the earthquake and all these things. It will take another 10 seconds or whatever, minimum 10 seconds. It will immediately, you can know that earthquake has occurred. Then the S wave is the dangerous wave, shaking wave. That shear wave will shake and building will collapse. So that wave takes, comes say after 30 seconds or 40 seconds or whatever. So during that time, you have sometimes 5 seconds or 10 seconds to 30 seconds or 20 seconds time, you have got hardly any time to really run away from the multi-story building or whatever. So people's life is not, I think only the good buildings can save their life. So earthquake warning system can save say you have got nuclear power plant that will automatically, shut down, or you have got that high speed train that can be stopped, emergency power can be stopped. So within 10-20 seconds time, the earthquake warning can be given that the S wave is on the way. P wave has already reached. Earthquake is on the way. The S wave is on the way. Within 10 seconds or 20 seconds, it's coming. So within that time, within say 10 seconds or 15 seconds, you can shut down some emergency, plants or whatever. So earthquake warning system is not really practicable for saving life of people. A tsunami warning system is practically used in everywhere, in every developed countries, and we didn't have it because of we had no history of that. So now we have it. So tsunami causing people's life is under much control. It can be drastically reduced. The other natural disaster is also being handled by meteorological department. An earthquake disaster can be saved by earthquake resilience buildings and construction. That is in your hand. I think I have clarified the points, and you understand now what is damage, what is seismic hazards, what is damage, what is risk. So these terms he started this lecture with these terms. You first try to understand these terms, and now I hope you are clarified. So if you have further questions, you can ask me, or you can ask Professor Jare, or maybe in his next lecture he will talk more, and that time also you can clarify your doubts. If you have got any clarification in my concluding this session, you can ask me right now. So I think this is what I wanted to convey you. You must be clear about and there is one question: animal behavior. The animal behavior, you see, I am taking some time because lot of doubts are there. Even people like you who are the cream of the country, going to be engineers, you have also many doubts. So common people, you can think how much doubt they can have. So the animal behavior, the earthquake prediction in our known history has been done once during the 1975 Haicheng earthquake. During 1970s and 80s, there are a lot of precursor studies, they call it. Before earthquake, a lot of things can happen. The Earth's resistivity can go down, the Earth's magnetic field goes down, or Earth's electromagnetic field emission goes down, water level goes down or goes up. Lot of things happens. So before earthquake or after earthquake. So started the precursor, we call it precursor studies before earthquake, whether you can do any signal you can record. So the earthquake precursor study were being done, particularly in China. They are doing still today. All other countries has almost given up. They are now concentrating, including India, concentrating on the microgeneration map and making earthquake resilient society. Earthquake will be there and you have to live with the earthquakes. Like Japanese are living with the earthquakes. You cannot stop earthquakes. You cannot predict earthquakes as of today. I repeat again. So the Chinese people, unlike in India, anybody and everybody predict earthquakes and it comes in the paper. Even the astrologers predict the earthquakes. There will be an earthquake in Northeast India, like that. All irresponsible statements they make, and it causes panic only. So China, you are not allowed to do that. No common people or no astrologer or no scientist even are allowed to do the earthquake prediction. The scientist will send the data, send the abnormal behavior of scientific data, say geophysical data, earth resistivity, they are measuring so many things, GPS and other things. So those data are sent to the earthquake prediction authority. And it is the prediction authority who will be only announcing the earthquake, if there at all prediction is possible. So even the villagers works like a team. They also report the abnormal going down of water table or spring discharge. All these things are sent to, say, from the villagers, from video block to the earthquake authority, prediction authority. Scientists also send the data to the prediction authority. So the prediction authority were in dilemma what to do. It really looks like something abnormal things are happening around Haicheng city area. Then they did not predict earthquakes. Then they found on next morning that lot of snakes and rats and all underground animals and insects are all abnormally on the road surface. It was abnormal, means it is a whole road is covered with the snakes and rats and insects and all these things. Then the earthquake prediction authority immediately predicted earthquakes. As someone questioned that animal can sense, yes, the underground animals like snakes and other things, they maybe there is some electromagnetic emission because of the earthquake. Before the earthquake, there is a fracture. The fracture, existing cracks are getting closer or getting wider or whatever due to compression or dilatation. So that creates some, like your static electric field. If you comb your hairs, you get some electric charge. Similarly, that type of electric emission can be sensed in the ground, and that can be also recorded by instruments, but you do not know where it is happening and when it will occur and all these things. So that type of signals, possibly the underground animals or underground insects and snakes and all, they cannot withstand, they come out. And so that was the only practically predicted earthquakes, means earthquake authority, prediction authority predicted on television and radio that you come out of the house, there can be a big earthquake, you come out of the house. So the people came out from the houses and they lived in the open ground and like tents and all. They lived one day, and within 24 hours or within a day or so, the large earthquake, 7.5 earthquake occurred in Haicheng, and the whole city was destroyed, but the lives were saved. But in same China, in the next year, 1976, the Tangshan earthquake occurred with a similar magnitude 7.6, and the whole city and the whole, people, lakhs of people were killed. So the message is that, Kyoto earthquake, I had been to Kyoto. In Kyoto earthquake, before 1980, all the houses, because before 1980, there was no earthquake design houses were made. They're all old houses. So before 1980, houses are all retrofitted, and after 1980, all the houses are earthquake resilient houses. I was living in Tokyo City, in a guest house, in the Tokyo University guest house, and one night, early morning or so, maybe 3 o'clock or whatever time, I had tremendous shaking. I was sleeping on my bed, And when it was shaking, I was not panicked because I knew that I am in Tokyo. That sense I had when I got awake. I found that it is shaking, severely shaking. I was not panicked. I didn't come out of my room. I was rather enjoying that shaking of my bed. I was, it was really enjoyable. And the next morning, I in the TV, I found there was a 7.6 earthquake in Japan. And the building was shaking and nothing happened to anybody. No people were killed. And in 6.3 earthquake in Kilari killed 20,000 people. So the earthquake do not kill people. It is your houses kills people. So the message is we cannot predict earthquakes, and we can make for you the microgeneration map. We can give you the frequency of that sites, at what frequency the ground amplifies maximum. So your building should not resonate with that frequency. You should take care of the frequency of that site where you are making any buildings or any construction. And you can see that Taiwan, if we have attended that international workshop, Taiwan bridge on the fault, and the dam was totally collapsed. That is the first instance in the world. So engineering construction should be earthquake resilient. So not to talk about the whether you can do prediction of earthquakes, whether you can make some high frequency seismic some waves to nullify the earthquake waves. You can think of that, and you can do when you are in a research level, and you can go do some research on that. Maybe next generation, your generation may be able to, by artificial intelligence, they may be able to predict earthquakes. But as of today, we can give you good maps, fault map, hazard map, microgeneration map, seismic risk map. Now you understand what is hazard map and what is risk map. That was my point to clarify to you. So the Earthquake Resilient Society is in your hand. There will be an earthquake in Agartala or in Guwahati on January 1. What will you do? You will evacuate the whole city for 15 days, 20 days, 30 days. So earthquake prediction is not a practical solution at all. We have to live like Japanese in the earthquake resistant houses only. That is the only solution. Even if I am able to predict earthquakes, that there will be an earthquake in Delhi tomorrow. So for today, you will evacuate the whole Delhi. 9.1 earthquake occurred in Japan, and there was no casualties due to shaking. No, I should not say no casualties. Hardly any casualties due to shaking. People are killed because of the 40-meter height of tsunamis. So again, I repeat, Earthquake Resilient Society is in your hand. With the help of GSI, maps and data, you must be doing good job for the society to make it an earthquake resilient society. Don't say that why it is not predicted. Even if I predict, even if we can predict, that is not going to solve, that is not going to save the society. Thank you so much. I think I have clarified the doubts, and again I repeat that you are the people who can make the society earthquake resilient. Thank you so much.
Thank you, sir. Thank you so much for your inspired, your lecture.
Yes,
And,
how are you?
I'm fine, sir. I'm fine. I'm just doing fine. I guess ma'am is here also.
Thank you, sir.
Thank you so much.
I think Jare sir is disconnected. So
Yes, ma'am.
thank you all the students.
Yes,
Tomorrow-
that is why I took up.
Yeah, tomorrow we will be meeting 12 IST. I request you, please convey the message to all the students. It is common for all the first year students, okay, for all branches. So convey the message that all should join for tomorrow onward classes. Thank you. Thank you,
Thank
Ansi. Sir,
Thank
bye.
you.
Sir.
Thank you.
Bye,
Bye,
sir.
Thank you, ma'am. Thank you.
Bye.
I think this, I try to induce.
Sir, sir.
So, yes,
you, sir.
thank you. Thank you.
Thank you.